Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everybody. Okay, this video is actually the second part of our content which is related to security engineering. The first part was covered in the class. Okay, let's go. In the part 3 of this video, we'll be covering security system design and security testing and assurance, and also the summary of the content of this slide. Right. So what you have seen just now is some example related to security requirement. It's not only about login or log out. So there are other more. You can set authorization. You can set how whether you want to put intruder detection requirement inside it. Okay, and then we take a look on how to record or document misuse case. Okay, it's like your normal use case diagram, but you put requirement that is related to security requirement. Okay, on how people can attack the system. So we have looked at how to identify the requirement. So let's look at how to design it. Okay, once you have identified the requirement, how do you design a secure system? Right? So security is actually non-functional requirement. Okay, so so one way of trying to design the secure system based on the security requirement that have been identified is through using architectural approach. Okay, architectural design. So actually outside there is uh, some strategy being suggested. If you want to have a secure system, uh, this is the way that you need to design it architecturally. Okay, so this is basically a big picture, identifying important component in the system in order to allow security, a more secure system, and also to apply good practices. Okay, so they are actually a set of practices that you can actually perform in your design and also in coding the system. It's more like a checklist that you can follow in ensuring that the system that you design is actually uh, more secure. Right. So I've mentioned just previously, if you want to have a secure system, uh, it will also actually affect other attributes or other non-functional requirements. Okay, it will affect the performance, right? Because there are so many checking involved, right? Before you transfer, you have to encrypt, and then when it reach the destination, it has to be decrypted, and all those is actually slow down the performance. It slow down the response time, and also it also affect on the usability, right? You have to remember very long password and you need to change it every 2 weeks, for example, right? And then additional interaction to complete the transaction. So sometimes the user become frustrated and they feel it's causes them more work. So the usability will be reduced, right? So there is also a risk assessment related to design. I think we have seen a risk assessment on the preliminary stage. So this is on the design stage. So this is the risk assessment done during design. Right, during this point of time, we have more information. We know what are the system platform will be used, what software, what system architecture are there, what are the data of the organization is available. So at this point of time, because we have more information, so we have decision which vulnerabilities will we need to identify or choose. Okay, so this is risk assessment done at design phase. where we have already the system requirement defined earlier. So this is the process during design. So because we have more information, so we have more choices of the technology available that we can choose to support the risk assessment related to support the system requirement. The same goes on the architectural design. Maybe there are several architectural design available to support the security requirement. So which one you want to choose? And then now that we have more information about which particular asset that we are trying to focus on, so all this information will be used to identify what are the risk assessment related to design that have been considered. And then because of this decision, maybe some of the requirement defined earlier will be changed or will be added. Okay, in the previous slide, we have seen activities done during system design where additional information have been obtained, right? So all that information have been fed into security design. So let's look at what actually happened during the design risk security design. Okay, so this looks like the same as what happened during preliminary risk assessment, but this is done during design risk assessment. This is done during when the system are being designed. Okay, so again, the same process happened. Okay, we need to identify what are asset related to design. Okay, so we need to decide the value, and if it happen, what are potential harm that can happen, and we need to identify a threat related to design, and then when it happened, so this at this point of time we are talking more, we have more information, so we know what kind of technology might be available out there, and also potential architecture that can be adopted in the system. So there are more choices. So from there we need to think about, okay, if what are the potential control suitable for the technology that have been chosen, and from there uh, the design and also requirement security might be changed, right? So the same risk assessment done, but done at design phase. Right, at this point of time, there is a need for protection requirement. So this is more related to whether do they want to combine, if there are some data related, do they want to put it together or not? All right. Uh, do you want to maintain copies of the record either at the client computer or at the server to avoid denial of service from happening? Let's say somebody attacked the server and it went down, so at least the system can still be running because there are copies at the client computer, right? So let's look at this slide. This is basically some example about some design decision related to commercial off-the-shelf system. Okay, so in this example, so when we are using a commercial off-the-shelf, meaning that you buy the system maybe from the internet, for example. Of course, system user will get a combination of password, right? And of course, this uh, maybe this COTS is actually a client server using architectural client server, where the client access it from their own laptop in the organization and access a server at the company's at the the software house that produce this software, right? Okay, like when you are using Google Gmail, you access it from your machine, but the actual server is handled at Google company, right? And then in this example, of course, it's using information is actually presented in editable web form, meaning that that form can be editable. Okay, can be edited. Right. So based on that kind of scenario, um, thinking about in this case, we are looking at the technology choices, right? Because this is at design phase, you already have more information about what technology is available out there that you can use. You can start thinking about the vulnerabilities, the hole, okay, the point of attack that can happen. All right. So based on the information given related to the COTS system, it says you use logging password authentication. So these are the weak point related to it. So maybe user of course will use guessable password, and sometimes you forgot your password. You call the software customer service asking for a new password because the the person in charge there does not know who you are. So it depends on just asking for uh, asking you some questions that can reveal who you are. If they think you are who you are, so they will might reveal you a password. Okay, and then because this is a client server kind of system using, this is related to architecture, right? So some possible vulnerabilities that can happen is that denial of service happen to the server. Some of the confidential information is being cached in the browser. Sometimes you store your password in the browser, or or sometimes browser security loophole. Okay, sometimes there are some security function in the browser that are not being turned on because the user is outside of the organization. Nobody advised them on which browser to be used, which function in the browser that need to be turned off in order to make it more secure. So this might happen. And then in this in the description just now, it said that the system is using editable web form. So because this is actually we are using COTS, maybe sometimes the system does not capture the log information, like who edit that file at certain time, what has been edited. So that was the data was not there, so you don't know, you cannot trace it back who performed the modification on the form. Okay, but and maybe because sometimes you give authorization on the system, but maybe among the user themselves they are sharing password, so you don't know who are actually doing the correction on the form. So this is how the based on the technology or the architecture of the system that are known during design phase, so this is the way that they identify the vulnerabilities. Okay. So at this point of time, the security requirement that have been defined earlier during preliminary can be refined or make it more detailed even more. All right. When, for example, you can, now that you know who are the user, where the system will be accessed. Okay, so you can actually make it more detailed by emphasizing, for example, access to the system are only allowed at the client computer, maybe in that organization. Okay, maybe a client should use a browser that have been installed by system administrator. Okay, we do simply allow the user to download different version of browser when accessing the system. Right. So at this point of time, because this is design phase, we already have some idea or some choices of architectural design. So at this point of time, there are also issues related to protection and also distribution. You need to be clear on this. What decisions are being made at this point of time in terms of protection? How do you want to organize the asset? Okay, do you want to put it in one place, or is it a separate place in order to protect it from external attack? Okay, this is about storing the data. Okay, distribution is most of the system nowadays are distributed, right? So how are you going to distribute the data? Do you want to store it in a different server, or where the data are going to be updated from time to time? How are you going to handle this in order to minimize the attack? Right? So we're talking about protection just now. So at this level, you are trying to think about how do you want to protect the data. So maybe it can be, yeah, it can be done in layer protection architecture, right? So protection at the platform level, at the application level, okay, specific protection mechanism built in the application itself, maybe like by adding additional password to allow only authorized user to access the data. And also protection can also be done at the record level, so the protection is only invoked or being called when access to a specific information is requested. Okay, you can put that special request only on specific important data. Right. So this protection can be done in the layer. So this is an uh, architecture layer related to the protection of data. Okay, so you can embed it at the protection level, platform level, at architecture application level, and also at record uh, layer before the actual accessing of patient record is allowed. Right. So we are talking about protection just now to protect the data itself. So this, when we are talking about distribution, is we are distributing the data outside already, right? How do you want to handle the attack? Is one system is being hacked when it was lost? How do you want to handle this? Okay, each platform has separate protection features, right? And it may be different from one platform, okay, because this is distributed system already. Maybe the platform being used in one organization and the other is different. Okay, so there are some different vulnerabilities there, and distribution is particularly important if risk of denial of service attacks is high. Okay, so in here it shows an example of what happened if a system being distributed, right? In order to ensure that there is no denial of service. For example, in this case, each branch, for example, is having similar data, okay, but specifically for that distribution, okay, for example, New York trading system is only having US data. Hong Kong trading system, for example, is having only Hong Kong data. In case one of the system went down due to denial of service, the other branches are still able to run as normal. Okay, so I mentioned just now during design phase, one way is to we can look at it from the perspective of archi- architectural. The other one is to best practice. Okay, best practice is normally recorded in the form of checklist, right? They capture all the best practice and they put it in a checklist, and that become design guideline. All right, so there's a checklist that you can always follow to ensure that you do miss common practice related to security. So these design guidelines or best practice is basically trying to raise awareness on the security issues handled by the security engineering team, right? And then it can is actually a basis of for the review checklist. Okay, so that during the validation, sometimes if you don't have this checklist, it will you the software engineering team or the team managing the security might miss some of the important element to be checked. Right, so these are some of the design guidelines for secure system. So this is a checklist that they follow to make sure that some of the important element is not missed. Right. So one of the guidelines here is that it advise so that the security policy, remember, this is among the things that need to be done at the organization level before any risks are being identified. We need to make sure that it is explicit. It needs to be as detailed as possible because it is the base of decision related to security. Right. So the second guideline is avoid a single point of failure, meaning that in case one of the security policy have been um, bypassed, so there should be other process that will be checking it so that you don't allow the attacker to come into the system. So for example, nowadays if it's to do with password, normally it will ask you for question based authentication, right? So what is your mother's maiden name, where do you stay, what is your additional questions just to prove that that's you. Or nowadays we have a getcha kind of questions, right, to make sure that you are the one that log in is not machine, right? The third guideline is fail securely, meaning that if the system fail, so important data are not being revealed or is not allowed to be accessed, it still remain protected. Okay. Right. Other design guideline is to balance security and usability. So they are actually the more secure the system is, the less usable the less usable it is, because you make it so strict that the user feel very uncomfortable using it. So you need to balance it. All right. So maybe some of the security function will need to be uh, left so that to allow the user to feel more at ease using the system. And then other guideline is to log user action. So everything that user do, for example, log in, what documents did modification at which part is actually being logged in is recorded, so that they are aware that whatever that they do are being recorded, so they don't do irresponsible action. Okay, when using the system. And of course, always use redundancy, have a lots of backups, multiple copies of data, and also have diversity, have various kind of infrastructure platform, just to avoid a single point of failure. When one system fails, there you have another backup. It does not fail because the infrastructure is different. And also make sure that all info format are being recorded. So you know what happens sometimes, you have attacker who key in very long query, very long key word in the search field, for example, and when they press search, it will crash the system. So when you specify the input, so the tester will know, whenever they are doing the testing, they will check for all possible inputs. So inputs which is too long, or inputs that allow some commands with it, is actually being checked before it is being processed. And then it's good to compartmentalize, meaning that whatever that your asset is, you have to put it in a separate place. Meaning that if one attacker get access to one of the asset, they need to actually try to find the other parts of the asset somewhere else. So it make it harder for the attacker. And then design for deployment, meaning that if the system is ready, you need to also identify what are the possible deployment problem, things that can go wrong where you want to install it, for example. So when it is run, so the things that can go wrong when the system is already running. And of course you need to design it for recoverability. So in case the system are being attacked, how the system will behave uh, to restore and to recover. So uh, I know this guideline is pretty broad, but in the actual practice, all these are actually being detailed out so that those are in charge does not miss important things, right? So we have talked about design just now, secure design. So nowadays, uh, the focus on security is not only on design but also in the coding itself, in the programming, right? So this normally there is a checklist, even sample of codes that you can run in order to identify vulnerabilities. All right. Uh, Normally they will ask you to check for example, array out of bound. Okay, to there are some even sample of code for Java, for HTML to check for inputs validity. All right, so I think you have learned about handling exception. Okay, when you want to run some codes, you also need to think about things that can go wrong with the code, so you try to handle it with exception. And then limit the visibility of information in the program, so that is actually achieved through object oriented, because some of the important information you make it private so that not everybody are able to use it. Alright, so you try to minimize error-prone construct, okay, things that you think some of the codes or variable that is easily create error, you are trying to minimize it. Alright, there is also timeout. You don't allow whenever you want to call external component, there's some timeout so that you do not leave it open for the attacker to intercept. And of course, this is basic. I think you have known this. Whenever you have variables constant, name it. Use readable name. Okay. Okay. So we have looked at design already, and how you can actually, when you are doing coding, there are set of things that you can check at coding level to avoid any vulnerabilities from happening. So let's look at how whenever the system is ready, now you want to test it, right? So this is test focusing on security. Okay, security testing and assurance. Right, so you want to be able to ensure that the system that you design are able to handle attacks, right, from external attacks. Okay, so you know that your attacker is intelligent, they purposely do this, so they want to find vulnerabilities in your system. So you have to ensure during security testing all the vulnerabilities are being handled correctly and covering almost all important or common vulnerabilities are being addressed. Right, security testing itself, there are many type. Right, there are security testing that are done using experience-based testing. So these are done by experienced software tester, especially those who have experience in this. They normally have their own checklist that they want to test based on their own experience. What special kind of certain kind of system, there are some common security attacks, so they normally test on that. There is also security validation that is done through penetrating testing, so they are actually trying to stimulate attacks. Okay, so these are it is done through a tool. Okay, uh, where they where it's not done by a tool. This is actually done by a team in the security team, where they that person is behaving like an attacker. This is called white hacker. So this is they try to behave like a hacker, trying to break the system. So when this happened, normally it is well planned. So everybody knows that that is a white hacker. so that they know when the system are being attacked, it is actually done by the staff in the organization, not from outside. So they know it is a well planned one, and it is basically trying to stimulate the attacks. Right, security validation can also done by tool based. There are tools that are being designed to check for password and all those, and also this validation can be done through formal verification. So these are more like a review where they review any formal security specification. They check it in the documentation to ensure whatever being recorded in the specification are being implemented in the system. Okay, so I've mentioned just previously, you can do security validation through formal review, right? Some formal review checking on the requirement. So they basically have the security checklist that they can refer to. They have, I think, out there, if you Google for security checklist, they have a common checklist that you can use, and you can use this checklist to check whether in the system do they have all these important action related to security. Alright, they check, for example, the inputs of the system environment, are they being checked against input specification? Okay, so what happen if bad form inputs are being input into the system? How do the system handle it? Okay, alright, just to wrap up what have been covered so far. So we are looking at system engineering. It is concerned about developing system which is safe against malicious attack. Okay, so we are talking about security threats. Okay, uh, threats can be threats against confidentiality, integrity, make sure that data is not being changed, and against availability of the system. You want the system to always be available. So we also discussed about security risk management. Why we mentioned about this? Because we want to smaller the scope. Maybe there are so many security risks out there, but we select the most important one for that organization. So it is concerned about assessing possible loss from the attacks that might happen, and by having this identifying the risk, it has security risk. It helps us to identify security requirement in order to minimize the losses. Okay, and in order to identify the security requirement, among the most important thing that you need to identify is the asset that you want to protect. So you need to identify what are the strategy that you want to do and technology that you want to choose in order to protect that asset. And then we are talking about security at design phase. Right, during design phase, normally the way to handle this is by through two approaches, through architectural. Okay, so nowadays there are actually available architecture to support secure system. There are several, so the team need to decide which one is best for the organization. And then during design, also another approach that can be followed is by using design guideline, which is best practice, where there is actually a checklist that you can follow to ensure that all important matters related to security processes are being checked, right? And then once the system is ready, the system are being coded using techniques or coding which is trying to avoid vulnerabilities. The system is already ready. The next stage is to validate the security to ensure that whatever being identified in the requirement are actually uh, put into practice in the system. Okay, you can either do security testing done by the experts, or using checklists, or to do penetration testing. All right, and you should have at the back of your mind that the attacker are intelligent. They are very diligent to identify the system weaknesses, so that you need to make sure that security testing are being done before the system is released. Okay, thank you so much.